I am happy to introduce the course Material Selection for Mechanical Design. I am Professor Bishakh Bhattacharya from IIT Kanpur, and the laboratory that I coordinate is Smart Material Structures and Systems Laboratory, famous as SMSS Lab. Now, I will briefly discuss about the course objective. There are three main objectives of this course. The first is that material selection is the core in any mechanical system design. So, any mechanical system you want to plan for, development and for manufacturing, you need to have some idea about the materials that you will be using for the particular product. And this field will then obviously integrate areas of mechanical engineering like design, like the mechanical performances, manufacturability, cost, sustainability and reliability. So, all these factors, all these 6 factors are important in terms of the material selection. So, through the course I will try to introduce you how all these 6 factors will create together in terms of a decision making for selection of a material. So, the emphasis of the course is engineering decision making. And remember that it is not just material science alone which will help you to do it, because that I have already covered in another NPTEL course, a MOOC course on nature and properties of materials. So, if it is only the material science, that course actually covers the ideas, but here it is the ideas of material science that needs to be integrated now for the mechanical performance, manufacturability and all the other 6 criteria that I talked about. So, what you will get from this course is how to translate functional requirements into some kind of a material index, so that you can actually sort of rank the materials and you can screen large material databases, how to screen them with certain criteria in mind, make trade-off based selections, because every time you want to gain some performance index, something you have to lose. So, these trade-offs I will teach you through actual real life case studies. That is the objective of the course. Now, I will just briefly describe about the why, what will be the impact of such course. You see, for example, woods. Wood is a material that is used for thousands of years. You think of this famous wooden chariot of Tutankhamen, gilded with gold. So, that is a sort of a transportation system. Why wood is used in such a transportation system 5,000 years before? And again, you think of another finest example from our own country, for example, the use of wood in the famous golden chariot of Lord Jagannatha. There also the wood is one of the primary material that has been chosen. Why is it so? Is it just because of the availability, or it has certain relationships with the material's performance, with the cost, with the sustainability? That is what we will bring out in this course. Let us take another extreme example. You know that today we are going more and more space bound. So, we think of aerospace vehicles. For example, we think of the re-entry vehicle. So, this is a very important class of space vehicles which is called re-entry vehicle. When you actually come back from space to earth, you get maximum friction, maximum temperature that gets generated. And also the other type of space vehicles that has to go for galactic missions, that has to go for interplanetary space mission. So, for such systems, why we use certain materials called superalloys, certain materials called composites. So, why these materials are specifically suitable for such purposes? It is from this course we will be able to know the reason behind it and how do we choose such a material. Now, I will just very briefly tell you that this course will have 12 modules. Modules 1 to 6 will be of 20 lectures. So, there will be broadly 20 lectures here, and in these lectures the first module is materials in the mechanical design process. A brief overview I will give. Then I will talk about various mechanical properties relevant to design. Then I will talk about density specific properties for lightweight mechanical design, and I will introduce the very famous SB material property charts, how to use it, screening, ranking and selection methodology part, how do we do that, so that a large group of material can be actually omitted and a very fine smaller list of materials can be focused on. And then again the performance indices, that is the most important part that we will gain at the end of this first phase. So, this phase 1 is important for us to create the basic background, and then we will go to the next 20 series of lectures. So, the next 20 lectures, and that will be from module 7 to 12, in which I will discuss things like slightly more involved like dynamic, thermal and other functional performance indices. How do we develop such indices? And then I will talk about the manufacturing process and material compatibility. Okay. So, first part is functional, that will be discussed first, and then the manufacturing process and material compatibility. Then I will talk about cost, sustainability, life cycle consideration, and then we will concentrate on case studies in different mechanical systems. I will first start with some traditional mechanical systems, conventional systems such as say automobiles or similar transport systems, or certain systems like a thermal system, or something like energy harvesting system, or something like a wind turbine blade. So, this type of cases we will first study, and then we will come to advanced materials like smart material. How do we select them? For example, here is one such case, right. So, this is a case where you have a composite, along with it there is a smart material that is embedded in it. Okay. So, different types of smart materials are the possibilities here. It can be piezoelectric, it can be magnetostrictive. Magnetostrictive is something like this. This is a powder. This is the etrima terphenol D powder. Now, this powder can be actually embedded inside this composite, and then you can get an actuator or a sensor integrated in the system. So, for such system also I will talk about how to choose the smart materials based on the performance indices. And then I will finally come to the very important core aspect that I want to discuss with you in the course, that is meta materials and meta structures, because you will then understand that there is something, if there is one single thing that can surpass these mechanical properties, is actually the geometry, the lattices. Okay? Be it a two-dimensional lattice system like this, where the lattices create many interesting properties such as acoustic cloaking, that you excite from one side, the sound wave will not go to the other side, or different types of other applications. For example, this one, another meta material which works like a shock absorber. So, you try to sort of apply force, as you can see from the bottom, and then it is getting local buckling, but the top part is completely saved from it. Now, how these meta structures are to be chosen, that is what I will be talking about in the final module. So, all these things together I will be covering in this course of material selection for mechanical design. And once again, a big thanks to all of you, and looking forward to meet you in the course. Thank you.